Assalamu alaikum students. So here we have another question and the topic is complex numbers, and the question is from May June 2015 paper 3-1, question number 8, and I believe that it is one of the technical questions and you must be able to solve this thing. So I've also mentioned this question in my list of benchmark questions for P3. So let's start with this. The complex number W is defined by W is equals to 22 plus 4i divided by 2 minus I, the whole thing is squared. Without using a calculator, show that W is equals to 2 plus 4i. So first of all, W is equals to 22 plus 4i divided by 2 minus I, the whole thing square. First of all, you will expand the denominator in order to get the denominator in the form of x plus iy, and then what you will do, you will take the conjugate of the denominator and then multiply it with the numerator and the denominator. So W is equals to 22 plus 4i upon a squared minus 2ab plus b squared. Okay, so 2 I and I. So W is equals to 22 plus 4i upon 4 minus 4i plus I squared. And since we know that I squared is equals to minus 1, therefore W is equals to 22 plus 4i upon 4 minus 4i minus 1. So 4 minus 1 is positive 3, and the denominator is 3 minus 4i. So W is equals to 22 plus 4i upon 3 minus 4i. We have got the denominator in the form of x plus iy. Now we will take the conjugate of this denominator and multiply it with the numerator and the denominator in order to get w in the form of x plus iy. So w is equals to 22 plus 4i times 3 plus 4i divided by 3 minus 4i multiplied by 3 plus 4i, which is a form of a minus b multiplied by a plus b. When you expand this, you will get a square minus b square. So a squared minus b squared. So 3 squared minus 4i squared. So w is equals to 22 times 3 is 66 plus 22 times 4 is 88 plus 88i plus 12i plus 16i square, and then divided by 9 minus 16i square. And since I square is equals to minus 1, so 66 plus 88i plus 12i plus 16 times minus 1. So what is 88 plus 12? This is 100. So what we can write, 66 plus 100i minus 16, since I square is equals to minus 1, and then divided by 9 minus 16 times minus 1. So 66 minus 16, this is 50. 50 plus 100i upon 9 plus 16, which is 25. So this is 50 upon 25 plus 100i upon 25. Since we know that 25 is a common denominator under both of the terms, 50 and 100i. So 50 divided by 25 is 2, and 100 upon 25 is 4. So 2 plus 4i is supposed to be your final answer. You will get your 3 marks for this working. Alright. So the next part is saying that it is given that the p is a real number such that argument of w plus p is greater than or equals to pi over 4 but less than or equals to 3 pi over 4. Find a set of possible values of p. Alright, let's just, is this working? What we know so far is w is equals to 2 plus 4i. And now we are finding the argument of w plus p, which we actually know that the least value of the argument of w plus p is pi over 4, and the maximum value is 3 pi over 4. So let's make an Argand diagram to comprehend the question. You will be, the question will be made easier for you to understand. Let me just extend this. All right. This is the imaginary axis, real axis, and the origin. All right. So basically, W is 2 plus 4i, 2 on the real axis and 4 on the imaginary axis. but w plus p, and since p is a real number, so basically we are moving horizontal. We are moving on the horizontal axis. Either we go in the right direction or the left direction, but we are moving horizontally. The vertical point is still the same. Okay, so p, I mean w plus p. If the value of p is positive, so w plus p would be lying somewhere over here. If the value of p is negative, w plus p would be lying somewhere over here. We don't know yet where it is actually lying. Okay, so let's consider this point as w plus p. This one is w, and if this is w plus p, so we are adding p to this thing in order to get this point as 2 plus p. All right, in order to get this point as 2 plus p. Now the thing is that uh, argument of w plus p had a least value of pi over 4. Okay, let's make it a half line from the origin. The least value of the argument is pi over 4, and the maximum value is 3 pi over 4. So pi over 4 is exactly 45 degrees. So 3 pi over 4 means 135 degrees. So 135 is obtuse. So other point would be lying in the second quadrant, and this angle is supposed to be then pi over 4, which is 45 degrees. This whole angle would be 3 pi over 4, because the argument of w plus p is greater than or equals to pi over 4, but less than or equals to 3 pi over 4. Okay, and obviously the argument of w will be greater than pi over 4. We don't need this thing right now. Okay, so let's just consider when the value of p is positive. When the value of p is positive, argument of w, the least value of the argument of w plus p, is actually pi over 4, right? So what we can see is that this w plus p, which is a complex number, if it is expressed in the form of x plus iy, what you can write 2 plus p plus 4i, isn't it? Where 2 plus p refers to the real part and 4i refers to the imaginary part, because the imaginary point is the same. Imaginary point is the same, no change in that. So what if I want to find the argument? Okay, so tan inverse b over a, tan inverse 4 over 2 plus p, and that argument is actually pi over 4. Argument is tan inverse 4 over 2 plus p, and argument is actually pi over 4. So according to this equation, what I can say is, I can say that 4 over 2 plus p is actually equals to tan pi over 4, isn't it? So 4 over 2 plus p, and since you know that the exact value of tan pi over 4 is equals to 1, so 4 is equals to 2 plus p, and therefore p is equals to 2. So if p is going on the right hand side of the point w, the p value is supposed to be 2, in order to satisfy this condition that the least value of the argument is pi over 4. Now what we are considering, the maximum value of the argument, and for that purpose what we know is that 3 pi over 4 is a 135-degree angle, which is obtuse, 135-degree angle from the real axis. Okay, because we are not considering this angle in the in the clockwise direction, because we will go outside the range of minus pi. All of the arguments are adjusted in the range of minus pi till pi. All right, so now the thing is that if w plus p is lying on the left hand side of w, we don't know right now where it is actually lying. So that argument is definitely, the argument is definitely 3 pi over 4. And what we know is that in that condition, the imaginary coordinate is still 4, but the real coordinate will go into the negative x-axis. You can say negative real axis. Makes sense? Because obviously, if the second uh, if the value of p is neg- negative, let's say if the value of p is minus 1. So we will be lying in the first quadrant. So there would be no sense of saying that the angle is 3 pi over 4. बात समझ आ रही है ना भाई? And if the value of p is minus 2, so obviously that point will be lying over here and the angle would be pi over 2. So definitely, since it is making an obtuse angle of 135 degrees, so this lying somewhere over here. Okay, so in this case, what we can say is that the imaginary part is still 4. Imaginary part is still 4. Okay, so what we can say is that tan inverse 4 over. But what we know is that the real part is negative. Real part is negative, but we will write it like this: 4 over 2 plus p, tan inverse 4 over 2 plus p. Now this argument is actually 3 pi over 4. So we can rewrite this equation in this form: 4 upon 2 plus p is equals to tan 3 pi over 4. And since we know that 3 pi over 4 lies in the second quadrant, and in the second quadrant the value of tan theta is negative. So tan 3 pi over 4 is supposed to be definitely minus 1. Alright. So 4 upon 2 plus p is equals to minus 1. So 4 upon 2 plus p is equals to minus 1. 4 is equals to minus 2 minus p, and therefore p will be equals to minus 2 minus 4, and therefore p is equals to negative 6. P is equals to negative 6. One way is to one approach is to do in this way, and here you get the final answer. The set of possible values of p are p is greater than or equals to minus 6 but less than or equals to 2. Now the other way is, just consider this quadrant. This angle is pi over 4. The argument is 3 pi over 4. Obviously, in order to get this basic angle of pi over 4, you need the real coordinate and the imaginary coordinate to be exactly the same. Ignore the minus sign because we are lying in the second quadrant. Just ignore the minus sign. Obviously, if this is 4, if this distance on the imaginary axis is 4, on the real axis I'll say that this distance is supposed to be 4 in order to get this basic angle as pi over 4. And as a matter of fact, this angle is definitely pi over 4 or 45 degrees. So what I can say is that on the real axis on the real axis my coordinates are minus 4 comma 4. Isn't it? Makes sense to you? All right. So in order to get this value as minus 4, you have to move 6 coordinates on the left hand side from W. Okay. I mean, this x coordinate of W is 2. In order to reach towards minus 4, you have to move 6 coordinates on the left hand side, 6 coordinates in the negative x direction. So obviously that p will be equals to minus 6. But formally, this working is more recommended. All right. I hope everyone is getting the point. And the p values, a set of the possible values are that p is greater than or equals to minus 6, but less than or equals to 2. Coming on to the last part, let me just erase this working. You, you will still need the Argand diagram for this part. Okay. Okay, so just read out the third part. The complex conjugate of W is denoted by W star. The complex numbers W and W star are represented in an Argand diagram by the points S and T, respectively. Find in the form of mod of z minus a is equals to k the equation of the circle passing through S, T, and the origin. Okay, I'll just make it on the next page. Because the space there is not enough. So here we have the real axis, here we have the origin, and here we have the imaginary axis. And W is equals to 2 plus 4i. So 2 over here and 4 over here. This is W, and W refers to the point S. And the conjugate of W, the W star, which is obviously the reflection in the real axis, because the real part remains same, the imaginary part just the is the sign of the imaginary part is converted. Okay, so imaginary part becomes negative, so that is -4. Since W is equals to 2 plus 4i, the conjugate of W is 2 minus 4i. This point is T. Now just read out this thing carefully. The equation of the circle passing through S, T and the origin. The circle must pass through the point S, point T, and this origin as well. Okay, let's suppose if this 2 on the real axis is the center of the circle. Just imagine this radius would be 4. This radius would be 4. But this radius is also supposed to be 4. And if we make a circle over here, is the circle passing through all of the three coordinates? No. Circle is passing only through S and T, but not through the origin. Makes sense? So, we have to find such a point which is the center of the circle, such that, you know, uh, it passes through S and T as well, and it passes through the origin as well. I mean, the thing is that we have to find such a center of circle. This is a main thing. So, for that purpose, if I make this whole scenario easier for you to comprehend, what I can say is that let's say I take coordinate A on the real axis, and let's suppose if this A is the center of the circle. Let's suppose if this A is the center of the circle, so the radius would be definitely equals to A. What is this value of A? We don't know yet. We have to find this out, and we have to express the equation in this form: mod of z minus A is equals to K. But the thing is that when this is the radius of the circle and A is actually the center, definitely A is supposed to be the radius as well. This distance will be A, and this distance will be A when this whole distance is A. Makes sense? So we need such circle. Now we are going to find, I've just made a rough diagram over here because we don't need an accuracy. We do the diagram is not required over here. When the sketches are required, then make a accurate diagram such that each and everything requirements are fulfilled. But here we don't need any diagram. What I've just told you that if this A is the center of the circle, so the radius is also supposed to be A. So we can say that the mod of Z minus A is actually equals to A. As simple as that. The equation given over here, mod of Z minus A is equals to K. I've just converted this thing into mod of Z minus A is equals to A. Now let's just consider this right angle triangle. When the radius is actually equals to A, this hypotenuse is also equals to A. The opposite side, the opposite side is 4. And what is this adjacent side? This adjacent side is A minus 2. Now we can form an equation according to the Pythagoras theorem. We can say that the hypotenuse squared is equals to adjacent squared, adjacent side is squared plus opposite side is squared. What we can say is that A squared is equals to A minus 2, the whole thing is square, plus 4 square. Since we know that this imaginary coordinate is still the same. Okay. So just solve this equation, you will find the value of A. Simple. So A square is equals to A square minus 2A, sorry, 2 times, 2 times, just use algebraic expression, sorry, A square minus 2AB plus B square. Okay. So A2 and 2. A square is equals to A square minus 4A plus 4 plus 4 square. Okay. So the equation goes like this: A square is equals to A square minus 4A plus 4 plus 16. So since this a square and a square will be cancelled out, minus 4a will go over here on the left hand side. 4a is equals to 4 plus 16, which is 20, and therefore a is equals to 5. Now we can say that the radius of the circle is 5 and the center is also 5 on the real axis. Now our equation of circle in the form of mod of z minus a is equals to k is z minus 5 is equals to 5, and this is supposed to be your final answer. All right. So if you found this video helpful, don't forget to like, share, and subscribe. Thanks for watching. Until next time, take care. Assalamu alaikum.